Good morning, classes. Coming live to you from the Colburn residence. Here is exponent sheet B, numbers 1 through 15 odd. Again, I have to do them in groups of 3 and 2 because YouTube does not allow me to upload large videos. All right, number 1. The first thing you should notice with number 1 is that there's an exponent on the outside. When there's an exponent on the outside, I like to distribute it in first. So it becomes P to the negative 7th to the second, Q to the second over P to the second, and then Q to the negative 8th to the second. Now you remember from last week that when you have inside-outside exponents, they get multiplied. So this ends up to be P to the negative 14th, Q to the 4th over P to the 4th, Q to the negative 16th. Now you take a look at what you have and you see, oh, there's negative exponents. That means my items have to relocate. So P to the negative 14th is going to move down, and Q to the negative 16th is going to move up. So now what you have is you have in the numerator Q to the 16th with Q to the 4th. In the denominator, P to the 4th with P to the 14th. Now you take a look and you decide, is that when I add or when I subtract the exponents? Well, the Q's are multiplying, so you add the exponents. So you get Q to the 16 plus 4 is 20. The P's are multiplying, so you add those exponents. So 4 plus 14 is 18, so you have P to the 18th. And that is the answer to number 1. And I forgot an eraser again. Give me a moment. Got it. Moving on to number 3. Number 3 says, parenthesis, negative 6, U to the negative 5th, V to the second, over negative 2, U to the 4th, V to the 3rd, all raised to the second. So again, I have a power on the outside, so for me, I think it's better to distribute it first, especially since these numbers aren't that big, and that's just a power of 2. So what you're going to have is you're going to have negative 6 to the second, U to the negative 5th to the second, and then V to the second, over negative 2 to the second, U to the 4th to the second, V to the 3rd to the second. That was just me giving the powers to everybody. Now negative 6 to the second means negative 6 times negative 6, that's positive 36. Negative 2 to the second means negative 2 times negative 2, and that is positive 4. Then these are inner outer exponents. Those get multiplied. So you have U to the negative 10th, V to the 4th, U to the 8th, V to the 6th. And you have one negative exponent to move, and that's the U to the negative 10th has to move down. So now in the numerator you have 36, V to the 4th. In the denominator you have 4, U to the 8th, U to the 10th that just moved down there, and V to the 6th that's there from before. Now you take a look at your exponent situations and you decide if you're going to add or subtract. So the V's are a division question, so those are going to subtract. The U's are a multiplication question, so those are going to add. So your 36 and your 4 are still the way they were. When you add the 8 and 10 for the U's, you get U to the 18th. Now, for the V's, you have to do 6 minus 4, so you get V to the second, and it has to be located where the larger V was, which happens to be in the denominator. So squeeze that in there, V to the second. Now, the last thing is 36 and 4 are reducible numbers, and you would never leave numbers unreduced if they can reduce. 36 and 4 are both divisible by 4, which makes 9 over 1. So your final answer is 9 over 1, U to the 18th, V to the second. And then if you don't like the 1 there, you actually don't need it because all the positions are filled up. And that's your answer to number 3. Let's move on to number 5. Number 5, we have 5r to the negative second times 2r to the negative sixth all over 7r to the fifth. Okay, so there's no outside exponents here, so this question is a little bit easier. So the first thing you're going to notice is that in the numerator, you have 5r to the negative second times 2r to the negative sixth. Well, the 5 and the 2 are regular coefficients, so you just multiply them. 5 times 2 makes 10. So you're going to have a 10. Because you have the same base, you're going to add the powers. Negative 2 plus negative 6 is negative 8. So you have r to the negative 8th over 7r to the 5th. You would never leave 2 r's in the final answer. So the first thing you notice is that r is to a negative power from here, that negative 8. That means that r moves down. The 10 is going to stay right where it is because the 10 doesn't have any power. So the 10 stays in the numerator. In the denominator, you have 7, r to the 5th, and then r to the 8th. And then you look at those, you say, oh, they're multiplying. So that's how it means I have to add the exponents. So what you end up with as your final answer is 10 over 7r to the 13th. And that's number 5. I'll be back in 2 seconds with the next 2.